Okay, this is lecture 4 from chapter 9. So we're talking about NPV profile. So NPV profile is a graph that shows the net present values for a project, or NPVs, for various discount rates or various required rates of return. So if we go to the next slide, so these are the NPVs for Project S and Project L. I'll actually do the calculations for Project S, at 0%, the 5%, 10%, 15%, 20%. As I mentioned before, as the rates go up, the present values of the front end loaded project become more valuable. So we can see that as we go up, the NPVs for Project S are greater than those of Project L. As we go down, Project L, because it's being back-end loaded with lower discount rates, becomes more valuable. So, but pull up our calculator. So, second cash flow, we get we have Project S entered. So, $3,000 initial cash flow, $1,500 first cash flow, $1,200 second cash flow, $800 third cash flow, and $300 fourth cash flow. So we hit NPV, and so we've got 0 entered, so we go down and we hit compute. That's $800. So now we go up and we change it to 5 and enter, and then we go down and we compute $454.89. Then we go back up and we change it to 10, enter, and then down and hit compute. We get the $161.33, and then if we go back up, if we change it to 15%, 15, enter, and now down and hit compute. So a loss of $90.74. If your required rate of return is 15%, you would reject Project S. So, and we go down, the NFV is net future value. We can actually calculate future values using our calculator. So 20%, so we're just going using all these rates. We go down and we hit compute for CPT, $309.03 negative. So we're able to recreate all these calculations. And go to the next slide. We have NPV graph on the x-axis and required rate of return or return on the y-axis. If we look, as we discussed, the Project L, the red line, is more valuable at lower rate, required rate of return, and less valuable at higher rates of return. And the opposite is true for Project S. There are 2 reasons that NPV profiles cross. The scale sizes, so smaller projects free up funds for investment. The higher opportunity costs, the more valuable these funds. Thus, higher R favors smaller projects. Probably more importantly, but as we saw, we have timing differences. So the Project S had a faster payback, while Project L had a slower payback. Reinvestment rates assumption. NPV assumes reinvestment at required rate of return IRR assumes reinvestment at the internal rate of return, so which may not be realistic, especially when it's above the firm's cost of capital. So reinvesting at opportunity cost of R, or the required rate of return, is more realistic. So NPV is superior. So NPV should be used to choose between mutually exclusive projects. So it ensures that the value is maximized. Cash flow patterns. So conventional cash flow patterns, 1 and 2 here, they have negatives up front. The second one here has multiple negatives. This is important. So when we're calculating IRR, every negative we have a second internal rate of return. The calculator Excel is going to pick the one that they think is best, but there's more than one solution to the IRR calculation when you have multiple negatives. So unconventional cash flows, so this one, project 1 here, has negatives in the first year and the third year, and then positives every other year. So, and then the second one here has negatives at the beginning, the first 2 years, and then the last 2 years. That would be a strange one, but it is not uncommon for a project to have negatives at the end of its life. There are many types of projects that will have costs associated with taking that project out of service. So this is going to make NPV a much more viable calculation. So as I mentioned, multiple internal rates of returns. This example right here, we've got a project with an initial cost of $1.6 million that generates $10 million in revenue in the first year, and has a cost of $10 million in the second year. Would be an odd project structure, but if we look at the NPV profile of this project, we've got two IRRs, 25% and 400%. Both of those would result in an NPV of 0. So we'll continue the next lecture with modified internal rate of return.